So in this video, we'll be looking at what we call binary operations. So binary operations is basically when you the word binary speaks of two elements or two terms or anything that deals with you actually working on two things, and the operation speaks of the regular four basic operation. You have addition, subtraction, multiplication, division. But what we'll actually do is include more than just the four basic operation, like a square root, cube root, and all of that. So when we talk about binary operation, what it really does, it actually calculates or it works on, like, say two elements, and that element will actually give you another element and so on. So let us actually look at what it is really saying. So if I have, so it is normally represented as this. So you have like a variable, and this is what we call an asterisk, and we say that this is equal to, just say this is equal to, say, x squared plus y, let's say 4y. And so what this is saying, if you should look at these over here, we actually have two variables or two terms or two elements, and so they actually working with these two terms. It's a binary thing, x and y. It could be a, b, c. It could be a, b, c, d, e, f, or any other two variables. But sometimes it is not always used an asterisk. Sometimes changes to, they could have any symbol. They could have something looking like a Pokemon ball or any other thing. So but what is the main idea in this thing is actually replace in the function or the whole expression, whatever that comes here, whatever represents x, what represents y, you actually substitute them into the expression. So let me give an example. So let's say we have 2 asterisk say 3. So what this is actually equal to, this, since x is the first element in right here, then anywhere we see x, we're going to replace 2, because as you look at it, x is the first, 2 is the first, y is the second, 3 is the second. So 3 is representing for y, and x is representing 2, or 2 representing x. So what we will do, we'll actually substitute 2 anywhere we see x plus 4 times 3. And there you go. You're actually seeing that these numbers actually substituting into the variables. And so we'll actually just go and evaluate. So we said 2 raised to the power of 2 is 4 plus 12, and that gives us 16. So that's simply it. So if we had something looking like this, so we had b, and so we had a little ball here, something looking like that. This just simply tells you what is really happening with these binary. So this one just telling us what is really happening with these terms. And so we say this is actually equal to, let's say, 3b plus, let's say, 2a. And so this is saying, whenever you see this, it actually represents this. So anything that actually replaces a, so if you should write any number, if you should write a 7 and write the same symbol right here, and we say 3. But the thing is that this represents 7, this represents 3. So anywhere you see these letters in the expression, you're going to substitute them into it. That's basically what is happening. So what we're going to use is 3 times b is 3 plus 2 times 7, because the A is representing 4, the 7, and the B representing 3. And then just go ahead and evaluate to give us 9 plus 14, and this will give us, let's see, 23. That's it. But it becomes somewhat challenging when we have something looking at this. If we had, say we had x, right, by the asterisk, y is equal to, no, if I say, yeah, right, let's say we have b squared plus 3, no, not b squared. If I have x to the cube, let's say minus y to the second. And if I should say, let's say 2 asterisk 1 asterisk 3. Now this is where most students are actually, they are just confused when they see 3 of them, because if it is binary, why are we seeing 3 of them when it's supposed to be 2? Because we know that x will be actually representing for the 2 and the y supposed to be representing for the 1, but what is this representing for? What is actually representing 3? And we don't know, but what we can actually do to solve this is to actually group one of them. So you can group that one. And so what will happen now, when we work this out, it becomes one term, or it gives you one value, and then whatever that is going to be the new, whatever this worked out to be, is going to be the new value of the y. And so let us look at it and see how it goes. So what we're going to do is to now use this for x and use this for y, because just as if we had 2 terms, any 2 term would be actually representing the y and the x. So if we wanted to do this, if we said, let's say we wanted to group, let's say we wanted to group the 2 first ones, it would be the same thing. This represents the x, this represents the y, and then when we get the answer for those 2, it becomes one term. And after it becomes one term, then it actually would just say when you work out these 2, you get 4. See, you get 4. Now this 4 will coming from this, and so that will be cancelled out, and that will be left with now giving us back the asterisk 3. And now we're having 2, which is like binary, 2 terms, and then we just actually do the same. X is for x and this for y. So it is no big deal to panic whenever you see questions like these. Very simple questions are very, very simple. So let's go. But it doesn't matter which one you want to group. You want to group the first one, or do just like the associative property. They grouping the first 2 and you leave one outside, or you're grouping the 2 last one and group and leave the first one outside. It doesn't matter. So let us try to use let's work it out as just as it is. So we say then this will be representing x. Anywhere we see x we put 2, anywhere we see y we put 1. So let's go. So it's equal to 2 raised to the 3rd minus 1 raised to the 2nd. So 2 raised to the 3rd will give us 8, and this gives us 1, so this is 7. And so when you look at it, these 2 is actually 7. And so if that is the case, what we're going to do is have 7 asterisk 3. And then we can actually do the same thing. Actually the same thing by just saying, they're saying this 7 now will represent the x, and this 3 will represent the y. So anywhere we see x we put 7, and anywhere we see y we put 3. So let's go. So we say now 7 raised to the 3rd power minus, what was y again? 3. 3 raised to the second power. And so we have to use the calculator to do this now. And so if we should actually say 7 raised to the third power, that will give us, let's say, 343 minus 3 raised to the second power, that will give us 9. And so our answer will be 334. And there you go. That will be our answer. Let us look. And so if we should actually calculate 7 raised to the third, that would give us 343 minus 3 raised to the second power, that will give us 9, and so this gives us 334. And so there you go. Coming from having 3 of them in the midst, let us just clear this up for some clarity. So this is having 3 of them in the midst, we just work any 2, because it's a binary, it's a binary system, and so binary means 2. So we're actually using 2, working on 2 first and so on. So let's look at a past paper question that and to see how we'll actually work a question like this. So let's look. So look at this. If you can see this, so it's given that a asterisk means square root a plus 4b, where the positive root is taken, determine the value of 1 asterisk 2. And then it's also said that we should determine whether the operation denoted by the asterisk is commutative. So let's look at this. So what we will actually do, let us use our whiteboard. So if we have, let's say, this mean of a plus 4b, and what we have, we had 1 asterisk 2. So what it is saying, this is representing A, this is representing B. So all we will do is just substitute them. So we say 1 plus 4 times 2. And if you should simplify the 1 plus 8, which is 9. And the square root of 9 is 3. So our answer will be 3. Now let us justify if this operation is actually commutative. I don't know what we say commutative mean. It doesn't matter the order in which we actually change the numbers. So if we say, so we have A and B. So if we have A and B, this is saying it doesn't matter how we probably do it. And we learned that when switching the numbers, it works with addition or subtraction, addition or multiplication. But depending on the operation that is there, because we did not explore if it were commutative, if it were commutative with certain operations. But let us explore and see. Let us go and try to see what is happening. So what we will do, we'll actually interchange the B and the A by rewriting this operation by saying, let's say if we so if it doesn't matter what we interchange. If we want to interchange these two, or if we want to interchange the variables, it would not make any big difference. So it doesn't matter which one. What I would rather to change this. Let us interchange this. So what we will rewrite it like 2 asterisk 1, and then what we will do, well, what we will do, we just substitute this for that and this for that. When we do that, then we'll have, let's say we have a square root 2 plus 4 times 1, and that gives us 6 square root. So it is not commutative, because when we had it in the original form, we got 3 as our answer. We actually got 6. So it is not commutative. It is not commutative. So it has to be in the original way. Well, whether we try it or whether we try if it is commutative, well, we tried it and it never worked. So that is just simply it. So that's just binary operation. Work in two terms and together plug it into the expression, simplify it. If you have 3 terms in it, you work with the 2 first, depending on which one is, which 2 is bracket, and then you actually just work out those 2. It becomes 1 term, and then that 1 term will join with the other one, and that will form an original 2, and then you just continue doing that. So that's simply binary operations. I hope this video will be a lot of helpful means to you, and you'll actually be able to understand the concept clearer. So remember, like, share, and subscribe if you enjoyed this video. See you next time.